T5 operation. Overview. Description. T5, or text-to-text transfer transformer, is a transformer-based model developed by Google that treats every NLP task as a text-to-text problem. It converts all inputs and outputs to text strings, making it versatile for a wide range of tasks. Key components. Text-to-text framework. Description. T5's core concept is to convert all tasks, whether it be translation, summarization, or classification, into a unified text-to-text format. This allows T5 to use a single model architecture for diverse tasks. Transformer architecture. Description. T5 is based on the standard transformer architecture, consisting of encoder and decoder stacks with self-attention mechanisms and feed-forward layers. Span corruption. Description. During pre-training, T5 uses a span corruption objective where random spans of text are replaced with a mask token, and the model is trained to predict the masked spans. Steps. Step 1. Description. Pre-training. T5 is pre-trained on a large corpus of text using the span corruption objective. The model learns to generate missing spans of text, improving its ability to understand and generate coherent text. Step 2. Description. Tokenization. Input text is tokenized into subword units using sentence piece, which efficiently handles both rare and common words and converts them into tokens suitable for the model. Step 3. Description. Input representation. Tokens are embedded into vectors, including positional encodings to represent the position of tokens within the sequence, forming the input representation for the encoder. Step 4. Description. Encoding. The encoder processes the input sequence, applying layers of self-attention and feed-forward networks to produce a contextualized representation of the input text. Step 5. Description. Decoding. The decoder generates the output sequence by attending to the encoder's output and applying layers of self-attention and feed-forward networks, predicting one token at a time. Step 6. Description. Task specification. Each task is specified using a textual prefix, e.g., translate English to French, summarize. The prefix is prepended to the input text to guide the model on the specific task to perform. Step 7. Description. Fine-tuning. T5 is fine-tuned on specific downstream tasks by training on task-specific datasets, adjusting the model parameters to optimize performance for each task. Step 8. Description. Inference. During inference, the fine-tuned T5 model processes input text with the appropriate task prefix, generating text outputs that fulfill the desired task requirements, e.g., translations, summaries, answers. Step 9. Description. Output generation. The decoder generates the final output sequence by producing tokens sequentially, conditioned on the encoder's output and previous tokens generated by the decoder. Step 10. Description. Post-processing. The generated token sequences are converted back to human-readable text, completing the text-to-text transformation for the given task. Advantages. Unified framework. Description. T5's text-to-text framework simplifies the handling of multiple NLP tasks using a single model architecture, reducing the need for task-specific models. Versatility. Description. T5 can be applied to a wide range of NLP tasks, including translation, summarization, question answering, and text classification, by simply adjusting the input prefixes. Pre-training efficiency. Description. The span corruption objective during pre-training allows T5 to learn robust language representations, that generalize well to various tasks. Considerations: computational resources. Description: training and fine-tuning T5 require significant computational resources, including powerful GPUs and substantial memory. Task-specific data. Description: effective fine-tuning and performance on specific tasks depend on the availability and quality of task-specific labeled datasets. Model size. Description: T5 comes in different sizes: small, base, large, 3B, 11B, with larger models providing better performance but requiring more computational resources.